There he goes. All right, oops. All right, I want to go over a couple of examples with our completing the square from the packet. The first thing, I looked at the 9.5 think about, and I was able to come up with the equations, right? We have our square, W plus L equals 75 feet for our fencing. I understood that, right? Put that in, we solve for L, 75 minus 2W will equal L. I know my area is 600, so W times L is 600. And then I substituted that expression in for L, W times 75 minus 2W equals 600. And they ask you to solve that, and they're like, yeah, right, it's not even factorable. So right now, without knowing how to solve this, what I did was I went to Desmos, graphed it, and looked for my zeros, and it was like 11.6 and then 25.9. It could be my widths, either one, and then I could plug that in to find my lengths. We're going to know a different way of solving these things that aren't factorable in the future. It's actually next section. It's not a perfect square, so I'm not exactly sure why they stuck that in right here. Pretty challenging question. But moving on to the 9.5 completing the square stuff. As I looked at these problems, there were a couple on here that you might have been like, I'm not sure how to do this. For the first part, it asks you to find C, so x plus 4x plus C. Find C that would make this a perfect square trinomial. Remember, when you're doing this, you're just taking half of B and squaring it. So 4 over 2, which equals 2, square that, and it would get 4. So x squared plus 4x plus 4 would be factored into x plus 2 times x plus 2 squared, if you remember. So that would make that a perfect square trinomial. So what you could do these pretty quickly. B squared plus 12b plus c. Just take half of that and square it. Half of 12 is 6 squared. 6 would be 36. So c would be 36 to make this a perfect square trinomial, which would factor into x plus 6 squared. What happens when you get to one where it's an odd number, like number 4? It gets more challenging, and without me being there with you guys, I'm going to try to keep it simple and not deal with these real challenging ones yet. But the process stays the same. I would take half of that, 7 over 2, and square it. And you end up getting 49 fourths. So a squared minus 7a plus 49 fourths would be a perfect square trinomial. Not simple to see, but if that guy factored, it ends up being a minus 7 halves squared. It's that guy right there would go in there, just like we did over here. Half of b is 6, that goes in there. Half of 4 squared is, half of 4 is 2, that goes in there. All right, so if it's odd, you end up with a fraction here. It makes the problem much more challenging, okay, but still doable. And then if you're looking at number 6, n squared minus 9n plus c. If you'd rather use a decimal, you could do a decimal. Half of 9 is going to be 4.5. This ended up being then c would equal 4.5 squared, or negative 9 over 2 squared. That would end up getting me 81 fourths. That would be that answer for C. If I were to factor it, I end up getting n minus 9 halves squared. That would be my factored form, okay? So what happens, let's see, that's that top part. Solve each of these guys. Again, when you get an odd number in there, like number 7, it makes your life much more challenging. So right now, I'd probably say stick to the evens if you had to for B, and then go back and try the odds later. Let's say we did number 10, c squared minus 4c equals 21. Notice I left a space here. All right. I don't need to bring this over. I'm not going to try to factor it, even though I could find two numbers, 7 and 3, that multiply to get that. I mean, this is factorable. But if we're going to use the completing the square technique, I take half of that guy. 4 divided by 2 is 2, right? Or negative 4 divided by 2 is 2. Negative 2 squared, you get 4. I add that to this side, add that to that side. This guy becomes c minus 2 if I factor it squared, right? Two numbers that multiply to get negative 4 combine to get positive two numbers that multiply to get positive 4, combined to get negative 4 would be this, equals 25, and then I would take the square root of both sides. C minus 2 is going to equal plus or minus 5. C equals 2 plus or minus 5. C equals 7 or negative 3. Okay? Try another one here. Let's say we had 16, or number 16 is r squared plus 8r plus 13 equals 0. Okay, this guy's not factorable. So the only way I can do this is, let's bring this to the other side. R squared plus 8r is going to equal negative 13. Let's complete the square. Take half of 8, which is 4, and square it. Add 16 to both sides. This guy factors now to x, or r, plus 4 times r plus 4, or r plus 4 squared, equals 3. Take the square root of both sides. R plus 4 equals plus or minus radical 3. And you could use a calculator, get a decimal there, or leave it this way. Bring the 4 over. Negative 4 plus or minus radical 3. And then again, if I wanted to check this on the calculator, I could do the square root of 3. Let's grab that. Second function, square root of 3. It's about 1.73. So negative 4 plus 1.73 and negative 4 minus 1.73. And actually get those values out, right? This guy would end up being 2.27, I think, negative 2.27. And this guy would be negative 5.73 if I did my quick mental math right. Okay, that's the process. Let's move on then. We'll do maybe 2 more here. I'll try to keep this under 10 minutes. Solve by completing the square. For 19 to 24, now they add another element. And again, these start to get real challenging. If